Hello, we are starting. Okay, good morning to all. Myself, Bhalachandra Joglekar, welcomes you all to this webinar on behalf of IMPROV Consulting and Knowledge Solutions based in Thane. IMPROV, in its ongoing attempt to introduce better practices and knowledge to the industry, has arranged this webinar on TRIZ, TRIZ, also called Theory of Inventive Problem Solving. This will be a 2-hour session divided into 3 parts. Each will be of 30 minutes each and followed by 10 minutes of question and answer. TRIZ is not a new concept to the industry and is in practice since 1940, but in the Indian context has been confined to a few large organizations. Hence, has not gained the prominence and following it deserves. This webinar is an attempt to bring TRIZ to the forefront of problem-solving tools and spread its application across the industry. Our focus would be to introduce you to TRIZ and create further interest in the subject. In the meantime, we are starting some programs to learn TRIZ and get further proficiency, of which we will keep you all updated. Now, to speak on this subject, we have with us Mr. Hemant Paradikar, who is a seasoned industry veteran with over 35 years of experience and has worked in various industries. He is a TRIZ practitioner and expert for the past decade with a level 3 certified proficiency in TRIZ as per international standards, which is the highest in India. He has also presented a research paper at annual conference of International TRIZ Association held in Graz, Austria in 2023. Gentlemen, please keep your mics on mute so that we can enjoy this session without distraction. I now welcome Mr. Paradikar to take up the lead and start the session. Mr. Paradikar, please.
Okay. Thank you, Mr. Joglekar, for a nice introduction. I wish to thank IMPROV Consulting for arranging this program. And most importantly, I would thank all of you who have joined today during weekend to invest 2 hours of theirs in this session. And I assure you, your 2 hours will be well spent. As Mr. Joglekar has said, we'll divide this into the 3 parts, and I want to make it as interactive as possible. So that is why 3 question answer session has been divided into 3 parts. And even otherwise, you may stop me whenever you want. But I think let us save the questions for the Q&A session of 10 minutes so that the flow is maintained. Already we are late by some little bit of time. So let us start. I don't know why. 1 second. Yes. What is TRIZ and how to use it? Now, in 25 years ago, very few of us knew Samsung or LG or Hyundai. In 25 years, they have gained global prominence. What are the factors which led to their success? One of the factors was TRIZ. Now in USA, there is a website called Patents 300. It gives top 300 organizations getting patents in USA, and it gives details of all those patents. Now let us see what is the result in 2023. Organizations getting most patents approval in USA in 2023 are Samsung 9,036 patents and LG 4,170 patents. There are only 250 days. In 250 days, 9,036 patents. These are patent approvals. I'm not even talking of applications. In this, Google is 9th and Apple is 10th in this list. What are they doing differently? They are using TRIZ for last 25 years. All the Korean companies in their R&D have Russian TRIZ masters working for them. For example, in Samsung, the Samsung Creativity Center at Suwon in Korea, the R&D head is one Mr. Oleg Feginson, who is a Russian. Now he has a nationality, South Korean nationality. And he is also right now president of International TRIZ Association. Samsung has 42,000 people trained in TRIZ. And now after Koreans, it is Chinese who have taken TRIZ in a very big way. Every year, tens of thousands of Chinese are being trained in TRIZ. And in patents, China has made compulsory for every person handling patents to understand TRIZ. So let's go ahead. South Koreans are not alone. These are also the companies who are using TRIZ. I see some Indian companies here, Infosys is here, ICICI Bank is here, and so on. So what is it? What is TRIZ? Let us look at origins of TRIZ. Henry Altschuler was the person who invented TRIZ. Altschuler was an inventor and a patent inspector. He studied with his student. He and his students studied 40,000 patents over 30 years to see if there is any master method of inventions. TRIZ was known to the outside world after disintegration of USSR because this guy landed in Saudi Arabian prisons for briefly, and there was surveillance on him, KGB surveillance on him, and that's why and then after USSR broke away, this person went to MIT in Boston and started teaching TRIZ there. Even today, the Altschuler Institute is in Boston. Till 2019, 25 million, 2.5 crore patents have been examined from the context of TRIZ. However, the basic structure of TRIZ remains unaltered. So, actually, TRIZ is extract of thought process of millions of inventors. Extract of thought process of millions of inventors. Actually, TRIZ is really not a theory. TRIZ is really, I must say, it's a collection of techniques. These are empirical techniques derived from all these millions of patents. My approach in this presentation is to give you a flavor of TRIZ and to avoid as much as possible technical jargon. Let's go ahead. Why bother to know TRIZ? There are so many creative methods. Why TRIZ? There is design thinking, there is theory of constraints, Six Sigma, value engineering, Kaizen, and so on and so forth. Why one more? What is that TRIZ has but these don't have? 30 seconds. TRIZ has two things unique. Strong idea generation method by addressing psychological inertia and resolving contradictions. All other methods use something like brainstorming for idea generation. But focus of TRIZ is idea generation. Second is strengths of evolution of technical systems, which have high predictive power of future evolution of technical systems and industries. This is lacking in these two things are lacking in other creativity methods. What is the innovation challenge today? Technology is developing rapidly, product cycles are shortening, communications are making world shrink, competition is increasing, going global. This trend will grow. How will Thomas Edison's method help? They involved thousands of trials. He was very proud of the thousands of trials, but that will not be helpful today. Now, what is the challenge for the industries? Due to globalized competition in industries, we need to have products with better features, better quality, lower cost, lower risk and hazard, early time to market, and within regulatory and legal compliance. TRIZ is a huge enabler under these constraints. TRIZ can greatly deliver under these constraints. Are inventive skills teachable? Is invention just as some kind of a God gift, or is it something there is a process of learning it? TRIZ says yes, it is teachable, but there with certain constraints. It's like learning to drive or to swim. There are very few self-taught swimmers, but many can learn and acquire different level of expertise. Level of expertise depends on one's talent, and practice increases one's skill. The more you practice, the more you become skillful. This is the biggest claim of TRIZ. You can invent not by just by inspiration, but by a structured thought process. This is the biggest claim of TRIZ. Now let us look at some few things about TRIZ. What is an inventive problem in the first place? The crux of an inventive problem is one or more contradictions. In a technical system, trying to improve one characteristics results in deterioration of one or more other characteristics, which as engineers, you must have seen day in and day out for years. If you try to have a motor which is which has a high horsepower, it consumes more electricity, it heats up more, or it creates more noise. So one good thing is coupled with another bad thing. The usual way is to find compromise by optimization method, which is to control the negative aspect to a tolerable level and to maximize the positive aspect. TRIZ says no. An inventive solution solves the contradiction without compromise. And the central focus of TRIZ is to resolve contradictions without compromise. Yes. This is common view of inventive thought process. This is a problem. You think of one concept, its variants, then second concept, third concept, fourth concept. You keep on thinking for like this for day after day, month after month. Someday you will hit the solution. This is the usual concept of Eureka. Random and uncontrollable. Now, what is brainstorming? This is some kind of a thought map of one individual. Now you superimpose thought maps of 10 individuals who are doing brainstorming. So that's brainstorming. And we hope that one of those vectors will be here. But it can get much worse than this. You are searching here. The solution is here in a different paradigm. I've just written this arbitrarily, but the point is the solution is in a different paradigm. So how can we reach there without trial and error? So let us look at what TRIZ does. This is a specific problem. It circumvents the barrier between problem and solution. It generalizes the problem by analogy and generalization into a generic TRIZ problem. For that, there is a lot of psychological inertia which is to be overcome. We'll come to this. Then generic TRIZ problem is used, TRIZ tools are used to solve generic TRIZ problem into generic solution. And this is converted into specific solution. And this is the time scientific knowledge is used. And sometimes there is also a psychological inertia here. So now next few slides, I'll go like this. First psychological inertia, then generalization, some TRIZ tools and how to solve. Let us look at psychological inertia. Am I audible and this is visible very clearly?
Yes, sir, completely. You are audible.
Okay, thank you. Okay, thank you. Psychological inertia, the monkey trap. This is a coconut with a hole here. And typically they keep a banana inside. And this is tied to a tree by a rope. Now monkey comes in and wants to take banana. Now the hole is big enough for monkey's hand to go in. But it is small enough for his fist with that banana to come out. And monkey is caught. It never occurs to the monkey that if he leaves his hand, he is free. Why it never occurs? Because in his life, food is the most important thing. But when freedom is lost, food is not the most important thing. But it never occurs to him. Where is the trap? Trap is here in monkey's mind. Trap is not in the coconut. So, how many times do we get into monkey trap? We get into monkey trap day in and day out, but not as serious as this one. This is because of rigidity of thoughts, because of preconceived notions, because of hidden assumptions, because of change of context, because of ignoring boundary conditions, and several other reasons. Now, how do you get out of inertia, psychological inertia? In fact, TRIZ has elaborate methods of getting out of psychological inertia. So, but to explain here, one of them is functionality. Primary means of overcoming psychological inertia in TRIZ is by focus on function performed rather than the physical structure of the technical system. Now, for example, in 60s, teachers used blackboard and chalk. Then came whiteboard and marker pens. Then came transparencies. Then came PowerPoint. Now we are doing PowerPoint. Tomorrow's PowerPoint will get replaced by something else, probably virtual reality or augmented reality instruments. But all these four perform same function. What is the function? To inform the audience. This is the function performed by Blackboard as well as PowerPoint. And tomorrow this function will be performed by something else. So technical systems keep on changing, but the functional delivers remain same. The quality of delivery, the method of delivery, that all changes. So TRIZ says focus on functions and not on the TRIZ says focus on functions and not on the technical system per se. Now let us look at one example. Washing machine. Do we wash clothes or make butter? I am talking suddenly out of context. You'll say what weird talk you're giving here. So what is function of washing machine? Inside the washing machine there is a pulsator. How does pulsator work? Earlier, our mothers and grandmothers, they used to have a handheld churner, and that handheld churner they would put in curd and churn. The action performed by the handheld churner is same as the action performed by the pulsator of the top-loading washing machine. And actually, in Punjab, they use washing machines to make butter on a commercial scale. What they do is put curd in a porous cotton bag inside washing machine filled partially with water and start the washing machine. Now, what else can we do with washing machine? In fact, washing machine has a dryer. Dryer is a centrifuge. You know what housewives are doing, including my wife, for many years. They are when they wash green leafy vegetables have a lot of mud and dirt in it, so they have to be washed and cleaned. But once they are cleaned, you have to remove the water, otherwise they will all putrefy very quickly. So what these ladies do is they put it in a cotton bag and start the dryer. Dryer is centrifuge. After 5 minutes, they are completely dry. The green leafy vegetable is completely dry. So if you focus on functions, you can see there will be unusual uses of technical systems. So this is something on psychological nature. This thought I wanted to leave with you. Now let us look at functions more. Functionality breaks silos, comparing apples and oranges and mangoes and bananas. Now let us look at 4 actions: brushing teeth, removing carbon from spark plug, kidney stone operation, and pink slips for non-performers. They all perform same function, which is to remove unwanted material. Now we can add another 25 or 50 to this list. So this is how generalization can help us to now to compare what is not comparable. Now let us look at some problems. Car tire wears more with speed. Microplastic leaches in bloodstream during transfusion. The military commandant has only 30 minutes to explain details of surgical strike to his soldiers. Now all these are same problems. What is the problem? How to reduce loss of material as the speed increases. As the speed increases, car tire wears more, or as bloodstream, if the transfusion is fast, there is more plastic going in. And here it is the retention by soldier. If he has 60 minutes, he'll be able to explain more and soldier will retain more. Likewise, there can be other examples. For example, when you hear a helmet, Mr. Jogle is calling. Hello? Hello, are you calling, sir? Hello?
I am not calling. I'll go back to mute.
Actually, I'm sorry, it looked like as if Mr. Joglekar is calling. I request if there is anything, you can unmute your phone and unmute your this thing and talk to me. Anyway, coming back to another example. Helmet. Wear helmet. It protects us from accident, but it is very suffocating. It is the same problem as a radio telescope must have a very strong lightning conductor, but that lightning conductor affects the feeble radio signals which coming from the space. Our third problem is nowadays high-rise buildings want a sprinkler in every room. This is a regulation now, but that the sprinkler spoils the aesthetics of the room. All these 3 are same problem, which is that to avoid a high impact, low probability event, we tolerate an inconvenience all the time. Contradiction. This is the central theme of TRIZ. I'm cutting out so much details of it, and I'm coming to something called physical contradiction. Cooking pan must be hot to cook food, but not hot for the housewife to hold. Hot and not hot. Wheels must be present for planes to take off, but not present as it adds drag on the plane while flying. Present and not present. Windows must be closed to prevent sun rays, but open to allow breeze. Closed and open. Hair dye must be highly reactive to dye the hair in 30 minutes, but not reactive for storage and sale. Reactive and not reactive. Likewise, we encounter a lot of uh, um, contradictions. A book must have large fonts to read, but small fonts so that the cost is less. You can have many other such contradictions. In fact, now how to solve this contradiction? There are three different ways to solve the contradictions. First is called separation, second is called satisfaction, and third is called bypass. Now let us look at first at separation. Separation has four main ways of separation. Taking example from earlier slide, separation in space. Cooking pan has an handle. Separation in time. The aircraft wheels are retractable during flying. Separation in relation. Window blinds allow air but do not allow sun rays. Separation at system level. Hair dye is stored in two separate inert chemicals and they are reactive when mixed. Actually, one of the best examples of separation space is ceiling fan. You know, if the fan blades are large, then there is a great breeze. But if you have a pedestal fan with large blades, it occupies so much amount of space useful to humans, and it can also be dangerous. So separate in space. So you can have as large as possible the blades, length of blades. At the same time, zero space is used. Likewise, separation of time, traffic signals, separate the traffic in time and allow it to go smoothly. And I can give several such examples. Let us go at satisfaction and bypass. Long distance runner needs long running tracks to practice, but there is no track in cramped urban areas. Use treadmill to practice at home. Invert the process. Bypass of opposite requirement. Patient needs to be urgently operated for kidney stones, but the patient is too weak and cannot be operated. Use ultrasound to pulverize the kidney stones, which will then flow out with urine. Bypass solutions always come from a very different paradigm. And in fact, my claim is that every contradiction can have a bypass solution. Even if there is a separation possible, there can be a bypass also. Let us look at some more TRIZ tools. How to resolve the contradiction? Start from ideal final result and work backwards. Normally, this is a riddle which we all know from our childhood days. Now, but today also, when there is a problem, technical problem, we start solving. There is a technical problem here. We start solving from here and go here like this, instead of going the opposite way. TRIZ says, postulate an ideal final result and work backwards. What is the ideal final result? The general ideal final result is there is no technical system, but its effect is delivered. Can we have a technical system with like this? In our mobile phones, we have a calculator. It has no physical existence, but its job is delivered. The function of calculator is delivered. TRIZ solution path. Identify correct problem using functionality and root cause analysis. I have not spoken about root cause analysis because it's generally known. So TRIZ root cause analysis is also very similar to the other methods. So that's why I have not discussed it here. Postulate ideal final result. Problem solves by itself with no cost and no harmful effect. Analyze why this cannot happen. Contradiction blocking the solution will be visible. There may be a chain of contradictions to be resolved. Resolve the contradiction by using TRIZ principles like separation, satisfaction, and bypass applied to existing resources. Now I am coming with another concept of TRIZ. What is resources? Anything within or around the system which is not fully used for the benefit of the system. Around the system, what are the resources? Air pressure, composition, gravity, temperature, sunlight, etc. System resources, texture, shape, left, right, up, down, orientation, chemical composition, density, weight, dimension, unused capacity, etc. Field resources, heat, electricity charge, electric charge, vibration, sound, friction, etc. Combination of various resources is also resources. Harmful effects are also resources. You know, something like gravity is a very underappreciated resource, or even shape. Why a particular system or a component should have a certain shape or a certain dimension or a certain weight? So many times it is not thought through. But thinking that can give sometimes really radical benefits. Let us look at resources. Use of resources for breakthrough solutions. Innovative solutions use free available resources, harmful resources for useful purpose, and make minimal changes in technical system. One such example of all three above is in daily life is pressure cooker. I'm trying to take as many examples as possible from our day-to-day surroundings. Cooker lid closes by itself when the steam pressure is harmful to humans and opens by itself due to gravity when it is safe. But if the cooker lid has to be closed from inside, the lid has to be bigger than the opening of the pressure cooker. But it has to come out, it has to be smaller than the opening of the pressure cooker. So lid has to be bigger and lid has to be smaller. So how is this solved? This is solved by separation in relation. And this is achieved by making lid lid of the cooker and the opening slightly oval instead of circular. So that at an angle of 90 degrees, the lid is smaller and it can go inside the pressure cooker. And when turned 90 degrees, it is larger. So just by making a small change in pressure cooker lid and the opening, this is achieved. So these three criteria are achieved in a pressure cooker just by, so it's a great design. Pressure cooker is a great design. And in fact, resources, one more example of resources is Mahindra had a problem with the tractor. There was a wire mesh jali and lot of dirt used to be stuck in that jali. And so a TRIZ expert solved this simply by making the jali inclined, so that when the tractor moves in fields, there is always a lot of jerks. If dirt goes, the dirt is moved by jerk and gravity takes over and the dirts fall down. So instead of keeping upright or erect 90 degrees, it was slightly tilted. And that solved the problem. So there was one more, but I think I can take this in questions if necessary. How much cooking gas is left? How do we know how much cooking gas is left without no instruments? I want to, this is the last slide before questions. TRIZ developers have compiled a database of scientific phenomena that can deliver certain functions. These can be used in final leg of TRIZ problem solving. For example, Oxford TRIZ database gives following. The function absorb liquid, for the function absorb liquid, there are 19 scientific effects, and these 19 scientific effects have been used in 45 different ways. For function compressed gas, there are 44 scientific effects and 39 ways in which they have been used. This is the URL of this. Anybody can access this database. There is another database called productinspiration.com, which is also gives something similar. There is also one database called patentsinspiration.com, But this patents database is not free. It requires some subscription. Now I'll stop here. Can we take some questions, please?
If anyone has any questions, please ask the question to Mr. Pardikar. This is about 10-minute gap. Then he will start again with the second part.
You can unmute and your audio, video, and then ask questions, please.
Any questions, please?
First question is always difficult.
I mean,
Can I ask one question?
Yes, please go ahead and unmute yourself, sir.
Yeah,
Unmute
I
yourself
have muted and I will ask. Yeah,
Yes.
I could see several examples which are really interesting.
Yes.
But one thing which I have not understood,
Mhm.
how did or what typical process of TRIZ made these solutions, or rather reach the solution or reach the whatever you call. 1 minute, sorry. Sorry, yeah. So I have not understood what is the method, what is the process by which you reach the solution. I mean, you explained the principles of TRIZ, right? You explained the various examples, that is also understood. But how did these examples reach the solution? What is the passage or route or method by which you could arrive?
Yes, I'm again sharing my screen. Sharing my screen.
Okay.
This is the solution path. First is working on the problem. What is the problem? First, clearly defining the problem. Then define a contradiction in the problem. Define the contradiction in terms of define the problem in terms of a contradiction. Then assume that it is solved. Problem solved by itself with no cost. Then first we identify the problem, assume that it is solved with no cost. Then it is never happens like this. Why the solution is not possible? If we think why the solution is not possible, there will be a contradiction. If we solve that contradiction, it is possible that we will encounter another contradiction. So if we go on solving like this, then there is a place when normally after 1 or 2 or 3 contradiction resolution, we reach a result. In fact, there is no a solution. So many times there are several solutions that come up. And while solving contradiction, we have to think not randomly, but focus on resources. What are the resources available? Can we use any of these resources, or do we have to add anything else? You know, generally the design of technical systems, there is a linear thinking process. The thinking process is like this, that if we have a function, add a component or a subsystem. You keep on adding, but then is there a requirement or something else can do it, or so this is what we'll discuss later. But this is the method of TRIZ. Actually, this is, I have oversimplified it, but it is that first, what is root cause? Let us look at one root cause kind of example. You know, in India, dishwashers have failed. Why have they failed? Because there are peculiarities of Indian cooking. Now, if you analyze the root causes, one of the root causes that organic matter sticks very strongly to the metal utensils. So it is the strong bond created between organic matter and metal utensils due to evaporation of water or due to partial burning. The problem to be solved is how to break these bonds and not the dishwasher. Probably these bonds could be broken better by not by electromechanical method, but by some kind of a chemical method. So root cause. So the problem to be solved is how to break these bonds. The problem is not of dishwasher at all now. So likewise, every initial problem can have a certain root cause. If you remove that root cause, then the entire problem is solved. So I think
Yes.
this is my answer.
Yes. A very good example. What you have told us is a principle of surface tension, I would say, which
Yes.
is broken by introducing a chemical into between the metallic surface and the coating which is sticking
Yes.
to it. Yeah, that's right.
Yes.
I mean, what
Evaporation
I
always creates. Sorry, go ahead.
no what I understood, understanding the root cause is the very first step, which is
Step.
very first step, and if it is very clearly understood the root cause in its true sense, then we are likely to reach the solution quite faster. If the root cause understanding
Yes.
is not so clear, then we may need more and more efforts to reach the
Yes.
solution.
Yes.
Right.
Absolutely.
Yeah. Okay. Thank you.
Sir, one more question.
Yes, please.
So you have mentioned a couple of websites right here.
Yes.
So where do these come into picture in this process? I mean, where does this database, at what phase do we need to look
Initially,
into?
let me again share. Initially, I have shared a graphic here. Finally, the scientific knowledge comes at the last
Kindly
stage.
share your screen. I mean, we are not able to see the screen. We are seeing your visual actually. We are seeing.
Oops. 1 second, 1 second. Sharing the screen. 1 second, sir. I will share the screen.
Yeah.
Are you able to see the screen now? Hello?
Yes, sir.
Yes, we can see.
So, this is the last stage. At this stage, you have to use scientific knowledge. And that is where the databases are helpful. All the scientific phenomena, TRIZ says you think in terms of what are the functions that the scientific phenomena can deliver. And according to the functionalities delivered, these scientific bases are arranged.
Okay. So you mean to say there is a external database that can be used for creating solutions here?
Yes and no. If you have an internal knowledge available within your own domain, then it is not necessary. But if it is not available, there is something else which is available to you.
Okay. So I think the primary difference here in other tools are this availability of external inputs which we do not see in other tools apart from the internal knowledge or the other learning that we look
Yes.
at
Yes,
during.
possibly.
Yeah,
Yes.
because in
That is
Six
one
Sigma
thing.
also, I mean, we have been doing a lot of of Six Sigma projects. Okay, this is not, I mean, and I'm listening to this for the first time. So I think this is something additional that the organizations can, take help from, right? To
Yes,
Okay, thank you, sir. Please
yes.
continue.
And second is focus on contradiction resolution.
Yes.
Actually, idea generation, whether it is Six Sigma or design thinking, everybody says, let us do brainstorming for idea generation. Here, the idea generation comes out of contradiction resolution.
Completely agree. Excellent. Okay, sir. Please continue.
So, let us go. If there is no questions, can I go to next segment? Or if there is question, I can answer. No problem.
You can go ahead, Pardikar sir.
Okay. Yes. Now, next part is of TRIZ is as the TRIZ was being developed, over a period of time, people discovered that all the technical systems, all technologies, without any exceptions, follow certain trends. And these trends are inexorable. No technology escapes these trends. Now, let us have some understanding of these trends. S-curve evolution in a technical system. It is like this S-curve. All technical systems follow S-curve. This is time, this is performance. Performance you can measure in any manner. Commercial people will measure in terms of sales and so on. Let us look at, there are 4 stages of S-curve. First is birth and emergence. A new technical system comes, it serves a new purpose, but is technically imperfect. Lot of human intervention is required. It is loss making, but this is the time lot of new patents are generated. And in the first stage, the technical focus is always on to make it work or to make it work properly. Today, if you see, AI is here. Artificial intelligence as now the birth and emergence of artificial intelligence has taken place, but it's still technically imperfect and loss making. Nobody is even talking of profits from AI. In 25 years ago, when websites came, everybody was talking of eyeballs. Nobody was talking of profits. So like this, then there is the second stage of growth and development also. This time, lot of technical developments happen. Rapid technical improvement happens. There is growth, rapid growth in usage, and it becomes profitable. This is the stage. And this is the time when the technical focus is how to maximize the performance and efficiency. And this is the time when the technical system becomes more and more complex. Then the third stage is maturity. Widespread usage is there, and there are high profit levels. And here the focus is maximize reliability. The cars were at this stage maybe a decade back. Today also cars are there more or less at the end of this maturity period. And then there is stagnation and decline. The technical system has reached its limit of its technical development. Many competitors emerge, better systems emerge, and profits decline. Here the focus is always on lowering the cost. Now, cars are more or less here, either between stagnation and final stages of maturity. But this one single S-curve is not the end of it. There is series of S-curves like this. When a technical system is moving on S-curve like this, there is certain revolutionary change happens. And this revolutionary change, there is a new technical principle based on which a new S-curve starts. But this new technical system is not profitable, not performing well, but over a period of time rapidly takes over and makes the old system obsolete. then this gets obsolete again. For example, let us assume this is the S-curve for landlines. Then this was in 1980s in Europe. This was the S-curve for mobile phones, feature phones. Then this is the S-curve for smartphones. So likewise, this will happen in every technology. One beauty about TRIZ is that it allows this kind of S jumps. You know, the TRIZ solution suggests this kind of S jumps. You know, you can jump from one S-curve to another S-curve. Many creativity methods are confined to only one S-curve, whereas TRIZ allows you to jump from one S-curve to another S-curve. All bypass solutions, as spoken, they are jump from year to year, always. So let us look at some certain properties of this S-curve. There is an overriding impact of super system. I'll come to super system. You know, premature death. Mobile phones sending text messages killed pagers. In early 90s, they were pagers in India. They started, I think they got killed in 2 years or something like that. Because mobile phones came and they started sending SMSs. So they got killed. LED bulbs, CFL lamps came, but soon LED bulbs have killed them. Now malls are being killed by online sales. You know, in 20 years ago, malls were the big thing. Now online sales are killing malls. So there can be premature death, or there can be a runaway jump. Runaway jump is like this. You know, when internet started and email came, that had great advantage over everything else. It need not go through this. Means there was no case for email being inferior to the letters by post. Some technology S jumps. Now, what is a super system? Super system is something in and around the technical system which affects, which interacts with it. So Kodak did not foresee the jump in S-curve from subsystem of image storage. So earlier image storage was on color films, and now it is on digital image. So Kodak did not foresee, and suddenly it was wiped out. Electric cars are due to jump in S-curve in energy delivery subsystem of the car. It is not a S-curve in the car, not a change in the jump in the car S-curve. It is the delivery subsystem of car, which is the energy delivery. Autonomous cars is a S jump in control subsystem of the cars. Instead of humans, the car will be controlled autonomously. Nokia did not foresee the S jump in their product to a smartphone, from feature phone to smartphone, and Nokia got wiped out. There was a time when Finland's 8% GDP came from only sales of Nokia. Artificial intelligence is a S jump in super system of information processing, which can threaten browsers. TRIZ trends. And there are, apart from S-curve, there are other trends. All technical systems without exception evolve certain trends. Most important trend is technical system evolve towards ideality. Now let us, I'll stop for a moment here. Like I'm wearing glasses. What is the function of glasses? It is to modify the it is vision correcting system. Glasses are vision correcting system. But then what is the function of the frame? It is only to hold the lenses. So really lenses are making vision correction. Now, what is the use of frame? Can we eliminate the frame? So if we eliminate the frame, we have contact lenses. Eye itself holds the lenses. And then we can think ahead of this. Why do we need lenses? Why can we not have a vision correction by correcting the lens inside our eyes itself? So nowadays there is a laser system by which it can be done. So, this technology has moved towards ideality. So like this, everything moves towards ideality. Sometimes ideality is achievable, sometimes not achievable, but the trend always remains. Like in our mobile phones, I'm right now running a timer or a clock, or there is calendar, there is calculator, there is voice recorder. Or these have reached ideality. They don't have physical existence. They are just programs, but their function is fully delivered. Then there are other major trends. Trend towards miniaturization, trends of uneven development of subsystem, trend towards increased degree of freedom, trends towards lesser human involvement, trends of merger with supersystem. There are 9 different trends. In fact, the trends have been, they keep on evolving, trends and subtrends, and there have been different TRIZ experts have classified them differently, and so on and so forth. But for every trend, there are well-defined stages within, and then these can be used to understand what is the possible future scenario. If there
Sorry,
are 5 stages, hello,
I'm sorry to interrupt you. Hello?
yes, go ahead.
It just
Go
came
ahead,
to my
please.
mind. Sorry, it came to my mind.
Hmm.
This particular list of TRIZ trends is the best inspiration
Yes,
for the developing ideas, either through brainstorming or your initial stage of
yes, I'm coming to that, sir.
etc. Because
The
these
next 2 3
points, if you look at these points, just ask this question: is it reducing my human involvement or not? Then the new idea may be generated. I mean, this is a very important slide, and we should keep it in front of us when anything is to be uh, brainstorming or root cause analysis to be conducted. This is a very useful list of TRIZ trends. Yeah, thank you.
I'm coming
Completely
to it,
agree,
sir.
sir. Completely
Next 2
agree.
slides. TRIZ says focus on evolutionary winners for innovation. So we can find out where the evolution might possibly happen. It may or may not happen because it depends on a lot of socio-economic, political conditions, mindset issues, cultural issues, and so on. For example, Whirlpool came out with a washing machine where there was no washing powder used. It was based upon ultrasound, but it failed in the market because of the power of Procter and Gamble and Unilever and all that. It did not take off at all. So evolution can happen, it cannot happen because of extraneous circumstances. But we know where the possible evolution trends can go. Now, this is what I want to emphasize. Now, this is a tool called 9 windows. This is thinking in time and space, past, present, and future. This is the system, technical system. These are subsystems. And this is super system. Super system is everything that interacts with our technical system, that is super system. So when as we were just now discussing on brainstorming of trends, start from here. Where is our stage system on stage of S curve? Where is on the ideality trend? Where is it on other trends? Do it for the subsystem, this is for the super system, then do it for the past where they were. And then we think in terms of where the future will go. And think in terms only of this S-curve and 9 trends. And every trend has defined stages. So we can think in how it will change, how the subsystems will change. Now in cars, all the changes are happening in subsystems. Car is always a car, but changes are having in subsystems. So likewise, if we think so many times super system changes will kill this. So like everybody is afraid that now AI will kill so many other things. because AI is something happening here. So if we, this is a format. Now this can be further expanded. All subsystems can be divided into 4 parts. First is energy providing subsystem, then transmission subsystem, then control subsystem, and then operating subsystem, which enables to provide the service for which the technical system is made. So if we do this and spend one day on this in terms of our own business, it will give such extraordinary insights using TRIZ for long-term survival. The pace of technology changes and increase in globalized competition makes business scenario constantly evolving. As change creates problem, it also creates opportunities. S-curve and evolutionary trends give systematic method of understanding future evolution. Couple this with 9 windows types thinking format to use to understand the above trends of super system, system, and subsystem. S-curve plus TRIZ trends plus 9 windows gives us objective method of creating possible future scenarios. So many times if we think do brainstorming, we get carried away, it gets into circles and circles, or it does not get into proper systematic directed method. This is a very objective method of thinking about future, ensuring long-term survival and growth. Every year before annual business plan, an evolutionary forecast can be done collectively by promoters and senior management. The conclusion should be taken into account for short and long-term business strategies. Collecting information on new development in super system and subsystem is a year-long activity. We need to keep on very alert. What are the new technologies coming? What are the competitors coming? What are the substitutes coming? And what is the international scene? What are how the tax system is going to affect us, and so on and so forth. There should always be information being collected on this, so that this 9 windows and trends we can use to not only survive, but see what are the tremendous business opportunities change is bringing us. Let us think positively on this. Actually, my son-in-law is doing, he has his business in advertising. So he is already learning AI. He is an expert in AI. So he says tomorrow AI is going to change advertising completely. So this is like this. So this is, I think I have done with this second part of the story. So can we take some questions now?
Sir, there is one question here. If you can go back to the 9 windows, can you give a few example on super systems? Because I think we would get more clarity on what you're talking on this whole concept of super systems, subsystems, and if you can shed one example on that, it will be more clear.
Okay. Let us start with subsystem. Every, TRIZ has classified subsystems into 4 ways. First is energy delivery. Let us take example of a car. The energy delivery in this car is, what is the subsystem? It is the IC engine, petrol tank, and so on, and the pistons and so on. And then there is a transmission system, which is gears and differentials and wheels and all that. That is the transmission system. Control system is brakes and accelerator, and then there are various dials, and there is a steering wheel, etc. And the operating part is what? The seats and the car frame, which enables the main purpose of car is to move human from one place to another place. So where does it operating part? Where is the operating part? it is the seats and the frame and the wheels, which is the operating part. Like this. Now, what is the super system for a car? Super system for a car is all surface transport. Not just surface transport. Even the transport by sea, transport by on water, transport in air. This is all super system for a car. Now, if we develop a car which flies, then car going on the roads will have significant disadvantage against a car which flies. I understand there are already flying cars, but they are still at experimental stage, not mainstreamed. So another thing is, in the super system of cars, there is financing. Now this actually it will come later, but I'll take them right now to explain. Why did Tata Nano failed? Tata Nano is a great car technically, very cheap. You know, one of my friends, he is also 70 years like me. He uses Tata Nano to go from Nagpur to Pune regularly, twice a year. Regularly, can you imagine traveling this distance by Tata Nano at 70 years of age? But Tata Nano allows that. But Tata Nano failed. And that time, the Tata's assumed that here, let us see here what Tata's assumed here. Tata Nano is good for, here, the Tata Nano is 1 lakh rupees price. The next competitor is Alto, which is 2.5 lakh rupees. So people will migrate from scooters to Tata Nano. That was the assumption. So but in super system, what is there? In super system, there is finance. All cars, nobody buys cars with down cash payment. 90% cars are financed. So what does finance do? Here, they would allow car to be available at at a down payment of say 20 to 25%, and to be repaid over 5 to 7 years. And so how much a person, if the price difference of 1 lakh and 2.5 lakhs appears more. But if you think in terms of financing a car, for Alto, you may have to give a down payment of 50,000 or 60,000 rupees, which is not too much. And people would think, why not buy an Alto, which looks like a regular car, whereas Nano looks so much like a modified auto rickshaw. Who knows 5 years down the line whether Nano will survive, but people know that Alto will survive. So even financing of cars is a part of the super system. Am I able to explain?
Yes, sir. Yes, sir. Yes, sir.
Anything else?
We got a picture, huh?
So any other question, please? My wife has been sensible. She brought in nice coffee for me as I was talking. Anyway.
Sir, you can continue there.
You may continue, Partika sir.
Okay. Now let us look at some TRIZ application. How process redesign or product redesign can bring radical benefits. Functionality, the radical advantages. It can transfer knowledge from one area of science and technology to any other area. This breaks knowledge silos and allows free flow of ideas. Functional analysis allows components to be classified according to a hierarchy of importance and cost of each marked properly. component of lower importance called auxiliaries and or components of which are of high cost can be eliminated and their functions passed on to other components. This is called trimming. We'll take examples of all this. Some essential features of inexpensive or inefficient systems can be transferred to existing system. This is called some essential features of inexpensive or efficient systems, not inefficient, or efficient systems can be transferred to existing systems. This is called feature transfer. And then there is something called function-oriented search. This allows to find solutions of one problem from one domain with solutions used in entirely unrelated domain. Let us look at one example. Testing of alloys for corrosion. A R&D lab of an alloy manufacturing company would test long-term effects of acids on cubes of alloy manufactured. The lab has only 2 gold-plated containers, so that the effect of acid on containers does not impact the testing results. Company diversifies into many different alloys. Now the lab needs more gold-plated containers. Management rejects the idea. Management says you are R&D. Find a new method of doing it. What to do? Now let us put an ideal final result. Acid reacts with alloy by itself. No gold-plated container is required. Now actually in this whole thing, the main function we need is reaction of acids on alloy. The gold-plated container is only a facilitator, which the function of gold-plated container is only to hold the acid against gravity. I'm hearing some voices. Can you request to mute your please microphones? Management, now the gold-plated containers do only the job of holding acid. So it is some kind of an auxiliary, in terms of, in TRIZ parlance, it is called auxiliary, which is that it does not do the main function, but it does a subsidiary function. Now, can we eliminate now this function of holding acid? Can it be done by alloy itself? If it can be done by alloy itself, then we don't need a gold-plated containers. So now, what are the resources? Why cube of alloy? Why cube of alloy? Why not a hollow cube of alloy? Or a container made of alloy? If there is a cube which has a hole inside, which is hollow, and you pour acid inside, the conditions are met. The acid will react with the cube. You can have 100 different hollow cubes. You can put different acids of different concentrations and test them simultaneously. No gold-plated container is required. So this is called trimming. This is the auxiliary. The function of auxiliary is passed to the main technical system. This is called trimming. Now, process redesigning, solution paths. Every process can be segmented into series of actions. Each action can be classified into 3 classes as follows. Productive, which contributes toward the final result and results in irreversible change. Providing, temporary change facilitating productive action. For example, if you have to bend a steel rod, you heat it so that it is easy to bend. That's a temporary action, which is a providing action. And corrective action is to rectifying defect created during earlier action. Useful action creates some defect So rectifying defect is corrective action. So process redesign path is like this. As far as possible, remove need for all corrective actions by introducing providing or productive actions. Remove providing actions by introducing or changing to productive actions. And high cost actions or high cost components should be a primary focus. In earlier example of this acid corrosion of alloy, we have seen that holding that gold plated containers which held the acid, they did a providing action. That providing action was transferred to the alloy cube itself, and then it became a productive action by itself. So the alloy, the gold plated containers were trimmed completely, and they were the high cost components there. Process redesign, some examples. Hot rolling mills have a problem of separating scale from water, which has to be recycled. How to increase efficiency and reduce cost significantly. Chandekar sir, this is the problem we discussed. And I have a different solution which we'll discuss offline, So I don't want to go into this solution here. But let us look at induction furnace. How to double or triple the profits with minimal investments. Induction furnace is a very tough business. 80% of the cost is the cost of raw material, that is steel scrap. Then 10% cost is the cost of electricity to melt that steel. And they baki sara khel 10% mein. Everything their gross profit, if it is most efficient, their gross profit is 2%. In fact, normally it is even less than this. Now what to do? How to double or triple the profits at net profit level? What are the resources available? In induction furnace, there is a heat going up. There is a lot of, sometimes smoke is there, but most of the time heat is going up. Lot of heat is going up. Can we use this heat in some way? Can we use this heat to preheat the steel scrap? Can we hang the steel scrap above the furnace in some way so that steel scrap gets preheated by this heat which is otherwise going to waste, and then we put this into the induction furnace? And I have seen a patent here where the patent claims that this reduces the cost of electricity by 37%. Now the cost of electricity is 10% of the sales. So which means 3.7% reduced. You add this to gross profit of 2%. So the gross profit immediately goes to 5.7%. Just by using what are the resources. Now, paper industry is highly water intensive. How to reduce water consumption by 90%? So what is the function of water there? The function of water is to spread the cellulose fibers and then to bind the cellulose fibers. And then how the cellulose fibers were bound was seen, then it was seen that they actually get bound when there is an evaporation of water. We all see that when there is mud, soft mud, when the water evaporates, it results in hard mud cakes. So likewise, that time all the solid gets bound to one another. Same kind of effect happens when paper is made and the cellulose fibers bind to one another because of evaporation. So if this is so, what is the need of so much water? Why not to use steam? And there are patents in here where the water consumption has been reduced by 95%. Just by looking at function. How to significantly increase the speed of electroplating with minimal changes. Now electroplating has a problem. If the temperature is high, the electroplating happens much faster. But the salt the salt solution, if we heat the salt solution, the salt decomposes. This is the problem. So how to solve this contradiction is to separation in space, which is the item to be electroplated. You preheat that item and then introduce that in the salt solution. So the heat is more where there is an interaction, which is called zone of conflict. I have not covered that. I want to bring as little as jargon as possible. So where there is an interaction between salt and the electroplate the object, that is where the temperature is more, and elsewhere the temperature is less. So the electroplating is faster. At the same time, and the salt does not decay. We have just now spoken about Tata Nano. This is one new concept which I want to introduce. What is main parameter of value? Innovate what? Where do we focus innovation? Main parameter of value is the feature which the buyer is ready to pay for. Now, main parameter, it is a common ground between what is the voice of the customer, what is the voice of the product, which is the features of the product, and the voice of competitive market, what dictates of competitive market. So it is this common ground, which is the called main parameter of value. Now, I'll give you another example from auto industry itself. Ford and General Motors came to India in 1990s. They had an early movers advantage. But last decade, they all went away. They could not break even though the Indian car market was growing by leaps and bounds, they were all stuck at a marginal level, and they went away. And later on, Kia came in. And now Kia has made a huge splash in Indian market. So what is that Kia saw which General Motors and Ford Motors did not see? It is the main parameter of value. Ford Motors had, if somebody asks a guy in Ford Motors, tell me in 30 seconds, how is your car different from other cars? They had no answer. That I call 30-second test of main parameter of value. So this is another TRIZ concept, main parameter of value. And this part, this is applied as much to a complex product as car or a computer as to a small screw. Somebody can say, ये सब मेरे लिए नहीं है. All this 9 windows and trends and all. I'm making a screw which I am supplying to my buyer. My buyer pays paying in time. I am happy. But tomorrow the buyer may not want that screw itself, because the buyer is a super system for the screw supplier. The buyer may replace that part by, instead of metal part, he may have some plastic part, or tomorrow he may 3D print that part, or tomorrow his buyer himself may get acquired by somebody else. Actually, this happened with my friend. He was supplying to one buyer like this. He was happy doing this for years together. Suddenly his buyer, he was an old man, it was run by an old man. His children were in America, not interested. So that buyer sold it to somebody. So now that new owner of that business, he said, thank you, sir, but I don't need you. I have my own supplier. So that is why this kind of 9 windows thinking is always very important. Long-term survival. Otherwise, there is always because in this technology change and various other things. There is always in hockey, there is something called sudden death. So in business, there can always be a risk of sudden death. Product redesign. This is a letter I received, email I received from Mr. Darrell Mann. His book, Hands-on Systematic Innovation, is supposed to be some kind of a Bible for TRIZ. He has more than 1,000 papers published on innovation. You can Google Mr. Darrell Mann. So I was reading his book, and he was making some statement, and I sent sort of a rejoinder to him. It was a polite, friendly rejoinder, and I made some kind of a sketch of a water filter which does not use backwash, and sent it to him. And I was surprised to receive his letter. And this was 2 years back. He said, "Thanks for staying in touch and sharing your very elegant self-cleaning filter design. I did a quick patent search to see whether anyone else has the same idea. And it seems that although there are one or two designs close, there are features of your design that are novel." Now see, I'm not an engineer. I was a banker. But TRIZ enabled me to create such a design which is a patentable idea. TRIZ is so powerful. In fact, I must give you another example. I can quote the name also. One gentleman called Mr. Anuj Garg. He is Dean at IIT New Delhi. He came from industry to academics. And when he was doing PhD, he had TRIZ level 1 expertise. But that enabled him to get 5 patents during his PhD thesis. I am quoting an individual by his name. And he one of the TRIZ presentations, he told this. So TRIZ has such possibilities. And so many times TRIZ has overlap. TRIZ, a product can always be considered as a process of the components. The components move in a certain predictable manner in a certain time sequence. So every product can be seen as a process, every process can be seen as a product. There is a lot of overlap in TRIZ. And in fact, people develop their own style of using TRIZ. So let us go to some other. So next examples. How can we have air-conditioned helmet without addition of components? Can we have hybrid of air conditioner and ceiling fan? A cup and a spoon designed for a Parkinson's patient. And how can a phone charger hold the phone by itself? Now phone charger is such a useless technical system. It needs 2 auxiliaries. The first auxiliary is a table or a window ledge or something where you have to keep the phone. If you don't have that, you cannot do the charging at all. So this auxiliary comes from super system. And then another auxiliary is the wire it has. What is the purpose of the wire? It only carries electricity, that's all. But it does not do anything in charging. Why do we need that wire itself? If the charging pin sits on the charger itself, and you can put the mobile phone on the charging pin, and the shape of the charger, instead of being rectangle, can be changed so that it can support the vertically standing mobile phone, then you can straight away plug it to the mains, and you don't need a support of a table, as well as you don't need the wire. In this way, both can be trimmed completely. So you can redesign that phone. I understand there are some charges like this. Now let us come to air-conditioned helmet. Helmet is very suffocating, as all of us know. How can we change? What are the resources available? There is a breeze when you drive. There is a breeze coming from the front. Now, there is sweat on the head. Now, how can this breeze somehow enter the helmet and dry this head? If we dry the sweat, the drying conversion of water into steam needs 452 or 436 calories of latent heat. Where that latent heat is going to come? That latent heat is going to come from the head, and the head will get cooled. And if you see even the way in which the air flows move, at the back there is a low pressure area created. If we see the wind tunnel examples of a ball moving through a wind tunnel and all that, so at the back of the ball there is low pressure area created. So there is a facilitation for the air to move from front to back through the helmet. Now, just changing I cannot show you the shapes here, but we can change the shape of helmet in such a way that there is no risk. Main thing is this helmet's first purpose to save the person from accident is avoided. At the same time, this is used to cool his head. If you see YouTube, there are some attachments at the back or the front with fan and all that, which cool the helmet. But these are deadly projectiles if there is an accident. So they are useless really. And let us take this cup and spoon designed for patients of Parkinson's disease. Now, again, coming back to helmet. Why do we need a helmet in the first place? Helmet is needed only in a very rare case of accident, but the suffocation is tolerated all along. So this is called functionality usability contradiction. It is because a certain function is provided, so usability becomes very problematic. Now the same auto industry has an airbag which is in four-wheelers. Why cannot we have a cap which is like an airbag and it absorbs sweat and evaporates and keeps the head cool? And if there is an accident, it becomes an airbag and protects the head. If you see YouTube, you will find some of these kind of solutions, but they are not mainstreamed. Likewise, now let us take this example. I have some more stuff, so let us take only one example of Parkinson's disease patients. His hands shake. How do you design a spoon for Parkinson's disease? Is there a technology available? Actually, it is. Noise cancelling headphones. What do noise cancelling headphones do? They take the random noise, convert it into electrical impulse, then give a feedback with 180-degree phase difference, and that cancels the noise. Same technology is used in large telescopes to neutralize the air turbulence. The scientific telescopes, scientific telescopes, they use the same technology to neutralize the air turbulence. They take the shimmering of the stars, convert it into electric impulse and give a feedback with 180 degrees phase difference. Can we do this for Parkinson's disease? His hand shaking is also random movement. Can there be some kind of a thick handle with him which has an electric device which takes this vibration, converts it into electric impulse and gives it back at 180 with 180 degrees feedback. So if we do that, the spoon remains stable. I have seen one such on YouTube. I have seen this made by one young student. So these are some ways in which product redesign is possible. Now let us look at some examples on shop floor problems. Hollow copper tube problem. There is a copper tube roll of 100 meters and you need to cut 1 meter pieces from it. The tube is hollow with thin walls and copper is a soft material. These are the two root causes of the problem I had. The cuts are irregular because it's very soft. You cannot cut it properly. And so there is another, so they have to be again smoothed with another tool. So there is a defect created. So this smoothing is a corrective action. Now, this results in a lot of copper dust going inside the tube pieces and creating a problem which is short circuit for the during manufacture final product, and how to have straight cuts of copper tube and no copper dust inside at all. The ideal final result is copper tube by itself allows straight cuts and prevent copper dust from inside. Contradiction is for straight cuts and no dust inside, copper tube must be hard and solid, but the copper tube is soft and hollow. This copper tube, mind you, there is still a roll. Only one end is open to us. Now this copper tube is soft. How can we make it hard and solid? Put some water from one end. We know how much water, volume of water, we know how much water we are putting inside. We know the internal diameter of the copper tube. So we know what is the water column which can be created. Now plug the open part, freeze this, invert this copper tube and freeze it. Now when freeze, the ice is created inside and ice expands. So the other side there is space for expansion. So copper tube will not break. So now the copper tube with ice is solid and hard. Just cut it. And then still some dust may stick at the cross section to the ice. So when you allow it to thaw, you put on a central pivot so that the two open ends droop downwards when the ice melts. As it droops downwards, gravity takes away the water, and with that, if there is any copper dust, that will flow away. So here you are introducing an auxiliary because existing resources are not enough to solve the problem. Now shop floor problems continue. Let us look at some of the shop floor problems. How did Intel, this is a very interesting problem. How did Intel solve problem of bubbles in polymer spread over the silicon wafer? Intel is doing all high-tech stuff. So they take silicon wafer on which there is a polymer called photoresist that they spread. And then they put a drop of photoresist and then they spin it. The spinning spreads it evenly. But sometimes what is happening is some micro bubbles, 1 or 2 bubbles come in. Now and then when the bubbles come in, when you spin, the bubbles move towards center and create what is called as a bubble track. If the bubble track is created, the silicon wafer is wasted. It has to be thrown to the dustbin. And it was a huge problem for Intel. And sometimes the losses were to the extent of 20%. What to do? So they tried to solve themselves, and then they brought some polymer experts and everything, but they could not solve. Later on, they approached a US TRIZ company called Gen 3 Partners. So what Gen 3 Partners did was, they said, okay, forget about polymers, forget about high-tech manufacturing. Let us look at bubbles and liquid. which are the industries where controlling bubbles is a life and death requirement. It's a shop. If bubbles cannot be controlled, it's a showstopper. So they identified three industries. First is blood transfusion. If there is, you cannot tolerate a single blood bubble in blood transfusion. Second is scuba diving. And third is champagne industry. Champagne industry has controls bubbles very well. So of all the three, they made some understanding what are the functions and how the functions are of stopping bubbles are performed in all the three industries. They created a three different solutions and told to Intel. And Intel adopted a solution which was used by champagne industry for over 100 years. It involved some kind of a what is called as ball valve. I don't know. I heard the CEO of Gen 3 Partners in a seminar, but he didn't tell me how the ball valve works for Intel and all that. But obviously, he did not tell. But he said the solution was there in champagne industry for more than 100 years. Now, let us look at another example. On an assembly line, soap is inserted in a paper box, which is then sealed. Sometimes soap dispensing is delayed and empty paper box is closed. How to remove each and every empty box? Each and every empty box. Somebody suggested X-ray solution and all that. Of course, everything increases cost. How can you solve it have a clear, most efficient, low-cost solution? Now let us look at resources. What are the resources? So empty paper box has low weight, has hardly any weight, whereas a box which has soap, which has significant weight as compared to empty paper box. So as the boxes come out of the assembly line, keep an exhaust fan. If the box is empty, it will be blown away. Each and every box will be blown away. So very simple solution based upon resources. Now, I can go on and on. I think essentially I have made the point. How to tame elephant in the room. Indian industry has high costs in global comparison. TRIZ has measured to radically, not incrementally, reduce the cost. Coming back to this Intel solution, there was a dairy in India which also had unexplained bubbles in the butter which they make. And they came to somebody, a TRIZ expert in India. And he used exactly the same method which Intel used to solve the problem. Okay, coming back to costs. TRIZ has method to radically and not incrementally reduce the costs. In fact, there is a 1.5 hour video on YouTube by one Mr. Simon Letwin, who was the CEO of Gen 3 Partners, on how to reduce costs. Amazing video. So how to do it? Focus on functions, not on objects. Same story. Focus on functions, not on object. Full use of resources. And then understand, you create what is called as functional hierarchy. Which are the essential components which are necessary for delivering a function? Which are the components which are auxiliary, which are not really necessary, but do kind of support work? And this auxiliary function components, auxiliary level 1, auxiliary level 2, there can be several level of auxiliary components. So, see what are the costs of these auxiliary components and trim them. and use this feature transfer and functional oriented search. This can be very significant, very effectively used to reduce the cost significantly, not incrementally. In fact, Simon Litwin's that presentation gave how GE could, with their high costs, could compete with the Chinese manufacturers by redesigning the product. Now, this is a TRIZ course of 3 days, which we are proposing. TRIZ participants will get... Hello? Hello? How to beat psychological inertia. I'm getting a echo. How to beat psychological inertia, understanding technical system from functionality perspective, solving problems by contradiction resolution, better forecasting ability of future development of technical systems, several techniques to improve technical system to give a competitive edge in the market. This is what we propose, a 3-day course. These are some reading references. In fact, this is a Vladimir Petrov, was one of the colleagues of Altshuler. The concept of resources comes due to Vladimir Petrov. He's an old man still alive. He now staying in Israel. He must be in his 90s or something like that. This is also, all these 3 books are very good. One more book is And Suddenly the Problem Disappeared. This is by Stephen Schaeffer. One more this is available on Kindle. And the last book I want to recommend is Da Vinci and 40 Answers by Liam Fox. This book, in fact, I found it on the internet. Da Vinci and 40 Answers. Actually, I have not gone into the technical details like 40 innovative 40 principles and other things, 40 answers, 48 name, 40 answers, 40. Thank you very much. I can, if India has to become manufacturing powerhouse, we need engineers who are innovators, who will create products which are evolutionary winners, first thing, and remain one contradiction ahead of the global competition. You'll always have contradictions. So you should be one step ahead in solving contradictions. So I think I can take questions.
Please ask questions. There is still 15 minutes available.
Mr. Redikar.
Yes.
So finally, if we look at it from the very top view of TRIZ, is there I mean, 4 to 5 sort of a macro step you can just verbally convey? The first is maybe understanding the problem. The second, maybe identifying contradictions. Maybe wherein what are we talking about in terms of subsystems or in terms of super systems? Can you just in sort of one line or so put this whole thing in the from a very 50,000 feet view, so that
yes,
since our all the participants are absolutely new and to this concept, so in sort of one liner, 1,
yes.
2, 3, 4.
The summary is like, if I may, let me gather my words. All technical systems evolve towards their ideality,
Yes.
resolving contradictions by focusing on functions, using mostly existing resources. If that is what if you want a quick summary, I think that is what is a quick summary. All technical systems evolve towards their ideality, resolving contradictions on the way by focusing on functionalities, using as far as possible the existing resources. Am I clear on this?
Yes. Since it is just a 2-hour session on a very I mean on a very new and sort of a I won't say difficult, but then a fresh kind of a thought process. It is we are trying to absorb as much as possible from
Yes.
yeah. But it was a very what I would say as a takeaway here is what Mr. Chander actually said, that slide in terms of functionality, in terms of human intervention. I think that was a good pointer that he said, and we would definitely love to learn more. 2 hours is a very insufficient time to know this concept actually.
Yes.
I mean, anyone else can, if they have anything to say, or maybe any sort of a question, please can ask.
I think
think
this
what
is what
Mr.
you are
Pawar-
saying.
I think what Mr. Pawar is trying to ask is there a roadmap that can be defined for the people who are a bit confused, maybe, because this is a totally different subject. Whenever we work in an auto industry related area, we are aware of what is FMEA, what is Six Sigma, what is 8D, what is 7QC tools. But that is a systematic way of approaching a problem or solving a problem. This is something which goes much beyond that. That is what is my
So,
understanding.
yes. So, you know, the first takeaway I must say is whenever you look at a technical system and its components or its components, look at what the function it is performing rather than what is its physical nature. What is the function performing? Then is the function performed adequate, or is it inadequate, or is it excessive? Is the function useful or harmful? Then if you make the functions like this, you will clearly see the problems. Actually, that is what is functional analysis. You know, functional analysis is a big name for these simple things.
Now, suppose somebody approaches you with a problem, industrial problem, or
Yes,
maybe from the
yes,
service industry. What do you think will be
yes.
total time duration? Will it be solved in a week or a month or a quarter, whatever? I know
It
it
can be
will depend on the
1 day,
complexity.
it can be 3 months.
Okay. Okay.
It can be 1 day, it can be 3 months.
Okay.
You know, it depends on, you know, so many times you need to understand if there is whether there is a solution in different technology. So you need to understand different technologies and all that. It may take 3 months, but it could be done in 1 day also.
Okay. Thank you. Anyone else wants to say something? Manish,
Yeah, we
would you like to
thank
propose a vote of thanks and say something about the whatever has
yes,
happened till since morning?
yes. We sincerely thank you, Mr. Chandekar, for enlightening us with this uh, with the concept of TRIZ, and we have been helping industries for a long time in different solutions. I mean, in terms of problem solving, this has been a new enlightenment to us as well. And what I summarize from this is we there is another what new that I've gathered is there is a sort of a bunch of database available also here when it comes to technical problem solving, which can be used to identify solutions, which was not found in any other problem solving tool till date. I mean, what we have implemented. So that is something that I have learned, and what I've seen is it is also looking at a 50,000 feet view, because a lot of times when we go into problem solving, we go actually too much micro as well, and then we lose a larger picture of the issue. So this, I think, TRIZ addresses that as well. So it looks at the micro as well as a very macro and the fundamentals of why we are doing the whole activity. I think this is another takeaway that I have personally seen here. And we really thank you for your time. Appreciate this session actually. And yeah, in case anyone wants to contribute, we can. Of course, the platform is open. That is it from my side.
I want to add something that Mr. Pardikar has given us a fresh, I would say, look at everything. Means problems are everywhere. Every day we have some sort of problem somewhere, and we are looking for solutions. But the specific approach which we found out, if we deliberately adopt it on our routine activities, the people whom we are dealing with together, we can have that kind of approach, and we can have a short sessions to look at each problem in a very specific manner using these techniques, and the solutions will come out faster than we just pass on the whole thing without paying sufficient attention to it. So I think this has given a new vision, new approach, new direction to set it in our routines. This is what I feel.
Agree,
Okay,
absolutely.
thank you.
Thank you.
So thank you everybody for patiently listening to me for 2 hours.
Thank you,
very much.
sir. Joglekar sir, you can.
Yes, thank you. I think whatever that all of you could able to gather from this session, we can start applying that knowledge or the process that has been told to us to solve your day-to-day problems from your working area, your industry. It can also help you to solve some of your personal problems also, if I'm not wrong. Maybe Mr. Pardikar can say that yes, you can solve
Yes,
your
yes.
day-to-day
Yes, yes.
household problems also. Am I right?
Yes, yes.
Yeah.
Yes, yes.
If there is nothing else to be contributed by anyone else, I thank Mr. Pardikar and the management of IMPROV Consulting Thane to arrange this beautiful and very useful webinar of 2 hours. Thank you very much all.
Thank you, sir. Thank you, sir.
Thank you.
So much.
Thank you, sir.